Hello, folks. Welcome to COP381, What's New in Amazon CloudWatch. I'm Abhi Khanna. I'm a product manager on the AWS Observability team. And with me here is Mike.
Yeah, I'm Mike Meany, a senior principal software engineer, also with AWS Observability.
Here's a quick overview of what we'll cover today during this talk. We're going to talk a little bit about what is observability. We're going to talk about observability at AWS, some of the common challenges that we've heard from customers like yourselves. We'll talk about all the new things that we've launched in Amazon CloudWatch to hopefully help with some of those challenges. Mike here is going to take you through some wonderful demos, and then we'll wrap it all up with some takeaways. Traditionally, when we think of observability, we think about it in three key phases. First, there's the detection phase, where you're trying to figure out what went wrong, where it went wrong. And then there's the investigation phase, where you take the things that you discovered went wrong, and you start to figure out why they went wrong. What happened? And then finally, as you start to figure out what happened, why did something go wrong, you start the remediation phase, which is all about figuring out how do you recover from the situation and how do you get back to a healthy state. And traditionally, we've thought of observability based off of three major pillars. Metrics for measuring performance characteristics as well as system components. Logs for diving into the individual event streams coming from different applications and system infrastructure components. And traces to understand the relationship between your different components and understand which pieces of the pie are potentially causing issues. As we zoom out here at AWS and think about observability overall, we give you a broad swath of options for enabling your observability use cases. From our Amazon CloudWatch offerings, including dashboarding, alarms, metrics, logs, and traces through X-Ray. And then we also have our open source observability stacks containing Amazon Managed Grafana, Amazon Managed Service for Prometheus, and Amazon OpenSearch Service. As we've been talking to customers, time and time again, we've heard that developers and DevOps personas, SREs, you're the ones responsible for making sure that the systems are always up and running, that you're able to serve your end customers, that your applications are doing what they need to do. Essentially, you're looking to make sure that your systems are monitored and issues that come up are easy to troubleshoot. And this has kind of resonated with us as we've thought about the challenges and the solutions that we want to enable for the people that are dealing with these issues. Let's go through some of the observability challenges that we've heard from customers like yourselves. Firstly, monitoring coverage matters. You really can't monitor what you can't measure. And the reality is that in today's world, you've got a variety of different application stacks running with a variety of different languages, utilizing a variety of different databases. You might even have a variety of different compute platforms, from containers to Lambdas to raw EC2 machines. And these all have to come together in order for you to deliver your applications and your use cases to your customers. And so it really matters that you're able to monitor and understand the behavior of every little component in that system. Coverage really matters. We're excited to say that now we have CloudWatch Database Insights. Woohoo. It gives you curated insights for Amazon Aurora databases with one unified view in CloudWatch across all of your fleets of databases. You get an immediate tie-in between the SQL metrics around the queries being run and the applications that those queries are coming from, so you can start to tie in where your database is degrading in performance, which applications are causing those degradations, and start to understand that relationship. It has an easy getting started experience with pre-built dashboards, so you don't have to go configure anything, learn about the right metrics to go monitor. It's available for you out of the box. And it's fully managed and requires no agent to be installed to actually turn on. The next thing that we've heard from you all is that as we've gotten to this world of lots of components with lots of different pieces having to come together to deliver value, that correlating data has become extremely hard. You've got so many EC2 machines. They may be interacting with load balancers, databases, caches, And oftentimes when you've isolated the problem down to one unit, you might be examining the metrics of that unit, say a CPU metric on an EC2 machine. And oftentimes you might want to pivot to the logs for the application there, looking at traces going through that machine, or looking at dependent resources like the load balancer sitting in front, or the cache or the database sitting below. And today this is complicated. Well, we're excited to say that with CloudWatch Unified Navigation, you now have a seamless, streamlined way to navigate across related telemetry and resources. With Unified Navigation, you get automatic relationship reveals that show you what the related resources are, giving you built-in key telemetry views of those resources, so you can inline start to understand, say, the EC2 CPU metrics associated with the EC2 machines underneath your applications, database metrics that are associated with the databases connected to those applications, all inline, streamlined, as you go through your investigation. It allows you to expertly navigate your entire dependency tree through the AWS CloudWatch console, and it's on by default. You don't have to configure anything. You don't have to turn anything on. It's available for you automatically. Time and time again, as we've added new data sources, sometimes we've created new silos. We've heard from customers that sometimes application data is in one data store. You have data in CloudWatch. You might be using OpenSearch for some of your application logs. And there's no easy way to bring all of that analytics capability over all of those data sets so you can get one unified view. Silos create fragmentation, which makes it hard for you to actually observe your systems. We're excited to say that you can now use OpenSearch on top of your CloudWatch logs for a better together experience for all of you. This gives you enhanced query capabilities like pipe processing language and SQL capabilities on top of CloudWatch logs directly from the CloudWatch logs console. It also gives you the ability to analyze your CloudWatch logs in OpenSearch alongside all of your OpenSearch logs without having to duplicate data into two systems. No longer do you need to have complex ETL pipelines to make sure that you're moving the data around to get you the analytics uniformity that you need. It allows you to leverage the best of CloudWatch and the best of OpenSearch, giving you that unified analytics view all in one place. Let's go back to that story about lots of components. The more components you have, the harder it is to figure out where the problem sits. It's important to be able to understand which spans or which pieces of your distributed system might have the problem as request issues show up. Oftentimes, you want to compare and contrast those spans with spans that may have happened in the past. Sometimes it's about finding a specific, unique problem with one of your requests across the many millions that your application might be serving. It all boils down to which component is causing the problem for either this request or many of the requests that often happen, and what's unique relative to the past. We're excited to say that with CloudWatch Span Analytics, you have complete visibility into your application transactions at any scale. You can ingest spans as structured logs, and the best part is that you no longer need to sample. You have an interactive visual editor to slice and dice spans, giving you all the analytical power to understand which spans potentially are related to the problem and how they compare to previous spans. Going back to that integration with OpenSearch, because these are stored as structured logs, you can also leverage all the same analytical benefits that exist with the merger of OpenSearch and CloudWatch to enable you to run those type of PPL and SQL commands over this data as well. You can leverage all the CloudWatch logs capabilities, such as pattern recognition and anomaly detection. And of course, it's one-click enabled for any AWS X-Ray customer. Being on call is rough. Being paged in the middle of the night while on call is even worse. Look, I've been there myself. It's very stressful to be woken up in the middle of the night. You have no context. Perhaps you were dreaming of eating pies, and now all of a sudden you're having to deal with an issue. And oftentimes, your customers are being impacted. Your leadership wants to have answers. This means you need to know what to do quickly, and you need to be able to make progress very, very efficiently. And while we do the best to prepare for these situations with dashboards and runbooks, sometimes our preparation falls short. Sometimes we don't have answers in the pre-built materials we have. And oftentimes I wonder myself in those situations, what do I do now? Ideally, I'd love to call a friend. I wish I could wake Mike up in the middle of the night, but he often doesn't return my calls.
No. Don't call me.
So we're excited to say with Amazon Q Developer Ops Assistant, you now have a friend in the middle of the night to help guide you through investigations. It gives you the ability to investigate and remediate operational issues, providing you hypotheses and observations that can help aid you along or guide you towards a root cause. You can initiate it automatically from alarms, kicking off those investigations, and the best part is that it can be ready for you when you wake up in the middle of the night with the suggestions pre-baked, so you can choose which ones you want to carry into your investigation and help refine the guided process even further. These investigations give you a collaborative space to share information, and they're end-to-end integrated with all of your ticketing systems, runbooks, and chat systems fitting into your incident response workflows. We don't need to have 3 a.m. be a scary time any longer. Quickly going through what we've just covered, we've added coverage with the CloudWatch database insights. We've made it easier to correlate your resources with CloudWatch Unified Navigation. We've removed silos and added more uniform analytical capabilities by combining the best of OpenSearch and Amazon CloudWatch logs. We're giving you deeper distributed tracing with span analytics. And finally, we've aided your investigatory process with Amazon Q Developer Ops experiences. With that, I'll hand it off to Mike for the more fun part and demos.
Thanks, Abby. So in observability, when we think of an operational event, we usually divide it into 3 phases: detect, investigate, and remediate. Now, 2 of these phases tend to be relatively quick. Detecting that there's customer impact, your alarm goes off, that generally speaking happens quickly. Remediating the problem when you know what's wrong, that also can be quick. The one though that tends to take the longest and is the most stressful is investigating why your application is broken or impaired. And that's the one you want to shorten as much as possible so that you can then remediate the problem. Now, sometimes the investigation it can be obvious. For example, you might have a dependency that is down and there's nothing really you can do except monitor the situation, report on customer impact, and twiddle your thumbs while waiting for the owning team to fix the dependency. Or there might have been a recent software deployment that lines up with the customer impact, and you simply roll back the software to the last known good version, and all is well. Now, speaking of rollbacks, I actually have a personal, very memorable rollback myself in my career. So before I worked on Amazon CloudWatch, I was on the team looking after the shopping cart page for Amazon.com. And you probably all know there's a checkout button there that you click when you're ready to order and give your money to Amazon. So in one of my greatest ever code changes, I managed to break that button for anyone using the Safari browser. So all of a sudden, people using Apple products were not able to order on Amazon.com. So that was a fun on-call, I can tell you. But the investigation was quick and the remediation was quick. We just rolled back the website to the last known good version and all was well. Well, except for my reputation, of course. But some investigations can be really tricky. Your application can break or be impaired in a way that you've never seen before. You go through your runbooks and the solution isn't in there. So that's when you need your observability tools, your logs, your metrics, traces, dashboards, to help you the most. And that's what these 2 new launches in CloudWatch do. They help you when you need it the most, helping you to get to root cause quicker. But before I jump into the demos, I'd like to set the scene. So I think we can all agree that investigating issues is by far the most fun when you're on call and paged in the middle of the night. So that phase starts with you happily asleep in bed when all of a sudden you're paged. So that's when you probably enter what I call the deer in the headlights phase. You're bewildered, hoping beyond hope that the problem is going to be easy to fix. But you may soon realize that it isn't easy to fix, that the solution isn't in the run book. And then in that case, you reasonably enter, the next obvious thing to do is to panic. So, but luckily enough, there's often help at hand. Maybe you page your manager into the call, or your CEO arrives, and they can be a great source of help, usually by shouting at you, demanding answers and solutions. So having set the scene, let's jump into the first demo. So let me describe the setup here. So you've just been paged into an event. You have an application, it's running on EC2. And the alarm is fired. So this alarm here is an alarm on load balancer server errors, so the HTTP 500 errors. So this is a very good metric to alarm on. So in your head, you know your runbook hasn't helped you. You looked at your dashboards, it's not obvious what the problem is. So in your head, you have an idea of what you want to do. You want to trace the layers of your application. You want to look at your load balancer health, then your target group is attached to the load balancer, you want to look at that. Then the EC2 instances attached to the load balancer, to the target group, and then even maybe to the EBS volumes attached to your EC2 instances. So before CloudWatch Unified Navigation, that was all quite a journey through AWS console, and you need to be fairly expert in knowing where to go and trace through the layers. But now with CloudWatch Unified Navigation, it's really easy. So you'll find just on the alarm page, there's a new button called Explore Related, and it has a compass icon. And that compass icon is your entry point to CloudWatch Unified Navigation, and you'll find that across AWS console. Particularly anywhere you see CloudWatch graphs or CloudWatch data, any monitorable resource in AWS, you'll have a look for that compass icon, and that brings you into the unified navigation experience. So I'm going to click on that button, or you're going to click on this right now, and you were looking at a single load balancer metric, the 500 error count. So what happens when you click the button, the Explore Related, is you get an instant dashboard of the health of your load balancer. So you see all the health metrics of your load balancer. So it's super easy to judge, is there anything else odd going on with your load balancer? So you can, first graph is API response time. The second one, that looks okay. The second one is requests, so you can actually check, was there maybe there was a massive surge in requests to your load balancer, and that maybe was the reason for the 500s. That looks normal. You can see the 500 errors here. So it all looks fairly normal except for the errors. So the next place you want to go is to your target group. So that's easy to do because at the top here, there's a topology map. So that's a live map of the resource you're looking at and nearby resources. So in this case, the load balancer is attached to a target group, or a target group is attached to the load balancer. So I just click on the target group and I see instantly the health of the target group. And again, the only thing that looks odd is the 500 errors that start right here. So then I jump down, then we've discovered that the instances that are attached to the target group, you simply click on the EC2 instance node, and you're then seeing the health of the EC2 instances. Super easy, click, 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 and I'm now looking at the EC2 instances running in my application. And that's when you spot something odd, right? There's one of the EC2 instances is running high CPU, the green line there. So at this stage, this is suspicious, of course. So the next thing you'd want to do, I think, would be to focus in on that one suspicious EC2 instance. And that's, with unified navigation, it's again super easy. So you just hover over the graph at the point of the high CPU, and below is displayed a leaderboard, and the high CPU instance will be the one at the top. So that's sorted in order of CPU, and you'll see down at the, let me just get it, down beside that, each instance is the compass icon. You click the compass icon, oops, I moved too quick, click the compass icon, and now you're zoomed in on that one EC2 instance, the suspicious one. So, and you can see the live map has updated to show you the instance has an attached EBS volume. It's in an auto-scaling group. And also, CloudWatch has discovered that there is a software service running on that instance and the other instances in your application. So this service node is actually very important because it's under the service node that CloudWatch also discovers logs coming off your EC2 instances. So again, I just click on, if I click on the service node and go to the logs tab here, the logs that were coming off, flowing off of the EC2 instances, they're summarized right here in line. I didn't have to know, remember, or have any domain knowledge as to what the names of the log groups are on those EC2 instances. I just click, 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 and here I am. I can see that there's 2 log groups there coming from those EC2 instances. And right at the top is a summary of the live log events that are coming off the instances. So obviously EC2 instances can be logging many, many log entries. But what we do here using CloudWatch Logs feature, pattern recognition, where we group together log entries that look the same and we display them, the summary right here, sorted by severity. So right at the top, you spot an out-of-memory error. So that's the only error line in your logs. So that also looks suspicious. You have an EC2 instance running high on CPU, and there's an out-of-memory error that's just appeared. Or, well, you're not even sure has it just appeared. You're probably thinking it has just appeared. So you'd like to verify, was that out-of-memory error always being logged, or did it appear recently? So without leaving the user interface, there's a nice compare button. So I click compare, and I can choose a period and click apply. And what it goes off and does is it takes the logs that are flowing from the instances right now, the log entries, and compares them to the previous period. And it does a pattern match, and then it does a diff inline. And right here, you can see that the out-of-memory error is tagged as a new pattern. So now you know that there's a new error that's just appeared in your logs. There's an out-of-memory error. You've got a hot running EC2 instance. So you're starting at this stage to form a hypothesis that there's one EC2 instance in your application. Probably what happened was it received a request, an unusual one. We often call these poison pills. So a poison pill is sort of an unexpected request that's triggered a latent bug in your application. Maybe that caused an infinite loop. The EC2 instance is now running out of memory. It's still in the load balancer. It's not completely unhealthy. It's probably still taking requests, but it's not able to process them correctly. And it's returning 500 errors to the load balancer and the caller. So at this stage, I think you know what you want to do. You want to get rid of that EC2 instance. So how do we do that? Well, then it's also really easy. In the map, I can just jump back to where you were. And now you're looking again at the EC2 instance. So when the map is focused, the focus of the map is on a single resource, there's a very handy context menu here. And the first entry in the context menu will be a link to bring you to the configuration page for that resource. So in this case, it's an EC2 instance. I click View in EC2 console, and I land on the problematic EC2 instance very, very easily. So I'll double check that it is the high CPU instance, and it is. So you can see that this really is the EC2 instance that is running high on CPU. So you just simply terminate that instance. You know from the map that the EC2 instance was in an autoscaling group, so the autoscaling group will just replace the instance, and that is your focus, mitigating the issue right now. You can, later on, you can then jump to the logs from that EC2 instance and maybe search and try and find the request that triggered the problem. That's the debugging phase you'll do after you've mitigated, or maybe after you go back to bed. You can do that while you're in the office in the morning. But for now, you'll have mitigated the issue by terminating that EC2 instance. So I talked a bit before about unified navigation being pervasive across AWS console. So here you are in EC2 console, the EC2 service console. And you'll notice that the graphs here, they're CloudWatch graphs. They've got a context menu, and they also have Explorer related with the compass icon. Or I can also hover on the graph, and there's a compass icon at the end here that I can click on. So if I click on the compass icon, I'm back into the now familiar topology map. I'm not in CloudWatch console, I'm in EC2 console, but I'm getting the same experience that I had. I can navigate, I was starting on the EC2 instance, but you can navigate back to where you started, the load balancer. Click on the autoscaling group, click on the target group, and then click on the load balancer. So again, without even leaving EC2 console, I can go back to the load balancer, look at the health metrics, and then check to see will the 500 errors stop. So that gives you a nice overview of unified navigation, how it can guide you through your resources and see the health of them. And it helps you can see how it's helped me get to the root cause faster. Now this particular error, EC2 instance running high on CPU, this is fairly common. We, in CloudWatch, we had a team I work closely with just this year had the same problem. And because we didn't have unified navigation back then, so it took a good bit longer to discover that there was a bad instance. And then it lengthened customer impact. But with unified navigation, super simple and super quick. Now, you might be thinking that, because I'm in EC2 console, I can only really navigate EC2 related resources, but you're able to actually look at any monitorable resource in your account from here. So, for example, that you might have in this account, you have a application called Pet Shop, and you'd like to see it's got a couple of databases, and you want to see the health of those databases. So without even leaving this, you're in EC2 console, the Find Resources is your friend here. So you click on Find Resources, and you can now filter through your resources by tag. So you tagged your resources with an application tag. So you type in application, it auto-completes the values of the tag. And now that you've chosen Pet Shop, this resource types drop down, filters down to just the resource types with that tag. You click on the resource types drop down, you look for RDS database instances, you click apply, and you're now looking at the health of those database instances right from EC2 console. So that gives you, I think, a nice overview of how pervasive unified navigation is and how it can lead you, and you can jump in at any point in AWS consoles and jump to the health of any resource in your account with metrics and logs. Another thing I wanted to show you before I finish up this particular demo is how well it works with CloudWatch dashboards. So I'm going to jump to a dashboard here. So this is a dashboard of various resources in your account, and it's a single dashboard of the health of load balancers, databases, and APIs and API gateway. And you've drawn a couple of key metrics: requests and latency for load balancers, and CPU and latency for databases. Some key metrics for those resources. But again, these graphs, like the other graphs, have the Explorer related. So if I go in and click there, even though I've only a couple of load balancer metrics on my dashboard, my key metrics, I can quickly just look at all health metrics for all load balancers on that graph just by clicking. And then I can close down that panel and then jump back in if you want to see the health, the overall, all the health metrics for these databases. Again, you just click Explore Related and you get an instant view of the health of all the health metrics for those databases. And then let's say you spot a graph that you think is really useful and you want to say, oh, freeable memory, that's a good metric. I should put that on my dashboard. So I can just simply click View and Metrics and add that graph to the dashboard. It's already pre-selected the dashboard you were still on. Click Add the Dashboard and you're back. You've just added that graph to that dashboard. You're back on the same dashboard and you're back on the same view into the database instances in the unified navigation. So that shows you how it's nicely, well, unified and it's very easy to use and is pervasive across AWS console. So let me switch back to the slides. So I think that's a good intro to unified navigation. One thing you might be wondering is, how do we link all of those metrics and logs to the map and your resources and your services? Well, CloudWatch built a new indexing service that as metrics and logs are flowing into CloudWatch, we relate them to the resources and the services publishing those metrics. So, and that powers this user interface. And worldwide right now, CloudWatch is making nearly 1 trillion associations between metrics, logs, and resources every hour. So another couple of things you might be wondering is, how much effort is it to turn this feature on, and how much does it cost? Well, the answer to both of those is this: 0. So there's no effort to turn it on because it's turned on for all AWS accounts in all commercial regions right now, and it doesn't cost anything to use it. So have fun using that feature. I'm sure it will help you get to root cause faster. So on to the next demo. So this one is a demo of the Amazon Q Developer Ops Assistant. It's an AI-powered ops investigator that will help. If you thought unified navigation would help you to get to root cause faster, well, this one will supercharge it. So there was another session, COP381-NEW, which is dedicated just to this feature. So have a look at that one. So I'll just give you a little taster of what this is in this demo here. So, so this ops assistant, you heard me use the word AI, and you're probably thinking, oh no, not another AI chatbot that I have to type questions into to get it to do anything. Well, you're absolutely right. It's not another AI chatbot that you have to type questions into to get any help. This one, amazingly, is one that just helps you automatically. So, and I'll show you in the demo how that works. So, switch back to the screen. So at the center of how this ops assistant, AI-based ops assistant works is another new CloudWatch feature we call investigations. And you can get a really quick intro and overview of what an investigation is by just going to CloudWatch console. There's a new section called AI operations you see here on the left. So if you click overview, try a sample investigation and walk through, I'll describe what you're seeing here. So an investigation is a bit like a ticket, and it's got a little tutorial as well that guides you through the UI here. I'll just exit out of that and describe what you're seeing here. So an investigation is a bit like a ticket. It's a place you record what you see and do during an investigation. And it's a sort of a shared document between you and your teammates. And when you see a problematic graph, you add it to the investigation. You might do a log dive, you can add that in. You might type in hypotheses or whatever. And that's what we call the investigation feed, is the panel you see on the left. And the panel you see on the right is suggestions, observations, and hypotheses that come from Amazon Q Developer. So that's where the helper stuff happens on the right there. So let me describe what we're seeing in the feed in this sample. So the very first observation is on the left. That was added by the engineer. And the very first one you see is a graph. And that's a graph of the original problem, the one that triggered the on-call investigation. So you'll see on the graph, it's basically an API availability graph. It was 100% and it dropped to around 95%. So that's the issue that triggered the on-call investigation. And the engineer that was on call then did a log dive. And from CloudWatch Logs Insights, he runs a log query, and the results he can just one click add them into the current investigation. And that's what that is here. And what the log dive showed was there's high latency writing items to DynamoDB. So that's sort of suspicious. So that's the limit of currently what the engineers found. On the right is what Amazon Q found. And the way it works is that when stuff gets added to the feed, so the engineer, for example, in this case, there's a graph of availability. When that gets added to the investigation, that's the prompt for Amazon Q Developer to go off and do its own investigation. You don't have to ask it, it just goes and does and investigates itself. It's a bit like, like with unified navigation, where you went and clicked and you went down and tried to get to root cause. This is Amazon Q is doing that in the background. That's part of what it does. All of that data that we said that CloudWatch was indexing, the Q Developer uses that to help it narrow to the right metrics, the right logs, to correlate and see if there's a relationship between some other metrics that might explain why the original issue happened. And you can see in the example here, the very first observation from Amazon Q was a graph. And you can see as I'm hovering over the graph on the right, the vertical line on the graph on the left, it all lines up very, exactly. So what the graph on the right is, the left is API availability. The one on the right is a spike in throttling to the DynamoDB table. So that's obviously suspicious as well. So if you're the engineer, you're looking at this and you say, ooh, that's actually very relevant. It looks very relevant to the problem, because in your investigation, you saw that there was high latency writing to Dynamo. You would click accept. So you would take the Amazon Q suggestion and say, that's right, I'm going to add it to the investigation. And interestingly, at the top then, you can see on the right here, there's even a hypothesis. So Amazon Q will even go to the level of figuring out what might be wrong. So it describes what it thinks went wrong, which is the misconfiguration on Dynamo, on the Dynamo table. And if you think, you'd read that and think if that's relevant, you would also accept that, and then that gets added to the investigation. And once you add it to add a hypothesis to the investigation, a hypothesis can come with actions. And in this case, a suggested action would be to scale up the DynamoDB table, and you can actually click on the action, and it would actually run and actually configure that DynamoDB table to give it more capacity inline right here. So that's the sample one. You can all check that one out in the CloudWatch console in US East 1 right now. So let me show you how you would investigate in practice. So let's say you're on you again often start off from an alarm, right? So you're on an alarm, and there's now a new investigate button. Besides the Explore Rated, there's now a new investigate option. And so if you had an alarm with impact, you can simply click Start Investigation. You'd give the investigation the title, something like Help, I am totally and, caps lock, and utterly lost. And you'll see here it has taken the graph from the alarm and added it automatically to the investigation. I click Start Investigation, and now there's actually no data on that alarm, so that's why it looks a bit empty. But the alarm then, the investigation starts, it takes the graph that was on the alarm automatically and it adds it into the investigation. So you can see there's already a trigger in there for Amazon Q to go off and do an investigation. So that's what it will do. It will start the investigation. It will look at related metrics, check if there's correlation between the metrics and the impact on the graph, and then add them to the suggestions tab. You'll see here. And then as suggestions come in, you will evaluate those as you're doing your own investigation. So speaking of that, so you know, you're not going to just purely rely on Amazon Q to do your investigation. You might be also using CloudWatch Unified Navigation, or you probably should be, to do your own, to investigate yourself. So let me show you how that works or integrates with Amazon investigations. So again, just like CloudWatch graphs have the Explore Related feature, they also have Investigate. So if you were looking at a graph here that, like these 500 errors, you'd say, ooh, that could be also related to the problem. You just click Investigate. It defaults to adding that graph to the current investigation, and you click Add to Investigation. And in that way, as you're investigating, you're adding more information to your investigation, as can be your teammates, and that's more information for Amazon Q to go off and then discover, and in the background perhaps come up itself with the root cause of the problem. So it's like a buddy that's there beside you at all times, helping you out. So I think that was the end of that's the end of the Amazon Q. Yeah, I think that's the end of that demo. So going back to the slides. Yeah, so this Ops Assistant, you know, it's like having a buddy by your side at all times, helping you along, looking around corners for you. So the days of being alone at night, on call, on your own, today they're at an end. From now on, you have the Amazon Q buddy to help you along, and look at things that you mightn't discover yourself. So takeaways from the intro today. One is, monitoring coverage matters. So if you don't turn on observability and observability products, you're not going to get as much information that will help you get to the root cause faster. So we saw like database insights, span analytics. Use these, turn them on, and the more you turn on, the faster it will be for you to get to root cause. Correlating telemetry is now easy. We saw the CloudWatch unified navigation demo. CloudWatch is seamlessly linking your resources to metrics, to logs, to services. Use it in your own human-driven investigations. Again, to cut down on investigation time, get to root cause faster. And from now on, you're not alone. The Amazon Q Developer Ops Assistant is there by your side to help you, to look around corners for you, and a great supplement to your own human-driven investigations. So that's all we had today. Thanks everybody for coming. Abby and I really appreciate you attending. We had a full house today. If you're going to replay tonight, I hope you enjoy yourselves. I might see you there. And Amazon is a data-driven company, so please complete the session survey in the mobile app, and I hope you enjoyed the talk. So that's it.